So good afternoon, everybody. My name is Yusuf. Thank you very much for making this session. I'm here with Gabriel and our team, as well as with Jason and Art, who will tell us more about how they're actually using the system. So today's presentation is about the new features we have in Microsoft Azure networking. We're going to be assuming you know something about our networking infrastructure. So this is mostly a breadth-first, quick overview of everything we've been working on for the last, 6 to 8 months or so. I have to admit, this is going to be a dense presentation with some demos, customer testimonials, and so forth. The good news is this. We managed to have this session the first day of Ignite, which wasn't easy. And the good news is we have 4 more sessions during Ignite. So if you want to know more about any of this stuff, we have 4 in-depth follow-up sessions, which I'll show you at the end, for any given area or areas you might be interested in. So quickly, the agenda is mostly about new stuff. It's about our cloud infrastructure at Microsoft and about new features that we'll be announcing. And we had issued a blog this morning, so you may have seen them very quickly. DNS, IPv6, a firewall for our application gateway, VNet peering, and a lot to do with increased bandwidth and lower latency for the cloud. I guess I'll give you the punchline. As of today, we have the fastest bandwidth possible in any public cloud today. And we'll see more about this in a second as well. And of course, we're going to have both Art and Jason tell you a bit more about how they use our platform, and a video from our partner, Aviatrix, as well, of how they integrate and solve solutions for one of the customers as well. OK, that's the plan. So a couple of customers will tell you how they use the system. You're going to see a demo and a video, and me talking very quickly. Very quickly, Microsoft, you've seen the slides from others perhaps. It's all about the global trusted hybrid. I know big buzzwords, but I want to tell you a bit more about the global part of it here. Guys, it's truly a global system. I mean, in our network, we are the networking team. We basically build, manage, automate the in-stack for this whole thing, from every adapter, including our own hardware, all the way to the global network, our own fiber in the ground, our own peering with partners, and so forth. We'll see more about this in a second as well. So Azure today has 34 announced regions across the globe. Each region, by the way, is typically multiple data centers. So if you see us say DC, we really typically are referring to a whole region with multiple buildings inside them. By the way, we meet the customer where they want us to be. Our whole strategy is to have the right footprint across the globe, because our customers have their own business needs. They have compliance needs. They have the need to have their data and computation in their country and so forth. So we have a huge footprint around the globe, which is frankly twice what Amazon has as far as a footprint around the globe. We have a huge network that connects all of this stuff. A first-class cloud is only possible with a first-class network. You can't have a bunch of regions and buildings and distribute across countries without having a first-class network that connects them. And our strategy is very simple, guys. We give you the ability to hop onto our network, either through the public internet, through a bunch of peering, or through private connectivity, through ExpressRoute. And once you land in our network, you're on our network. We'll get you to your data. We'll get you to your region, wherever that may be. And the private connectivity part is through ExpressRoute, which is really a way to get very close to your data, and peering points very close to our region as well. And you'll see a bit more about this in a second as well. So Netnet, we have a global footprint, not only with regions and data centers, but with a first-class network that connects everything together as well. This is a busy slide that basically describes what our team does, to be quite frank. In a nutshell, this is an end-to-end networking story. Starting from the left, you have the actual physical servers where VMs run. You have the physical network in there. Within a given Azure region, there's a lot going on behind the covers. Because, guys, as you probably know, this is a multi-tenant, virtualized environment. Your workloads run on the same infrastructure, so we separate them securely from each other, we visualize them, and so forth. We have security and isolation between the virtual networks. We have performance isolation. You'll see about numbers in a second as well. We have built-in services like load balancing, NATing, segmentation, you name it. Everything's virtualized. And we can connect you, of course, if you wish, between your regions and your on-premises through a plethora of technologies as well. The trick is, this stuff is software automated. When you call for API, when your packets go through a network, trust me, our guys are not sitting there watching what you're doing. Actually, many of them are in this room at the moment, and the cloud is running just fine. This is all first-class SDN-class network, guys. And this is a kind of SDN software, by the way, guys, you cannot buy off the shelf, because few people ever had to build a cloud of this size. We have the WAN that connects everything, the previous nice global picture I showed you. The WAN is a global wide area network. In some regions, like in the US, we actually own our own fiber. We light our own dark optics all the way up. And otherwise, we have submarine cables across the globe, and we manage a global IP network, which everything runs on this stuff, end to end. And of course, ultimately, you as a customer, as a partner, you have to be able to get to this network. So you get to it, of course, through multiple means. You can read the red box in there. But basically, we have our backbone in more than 100 exchange points around the globe. Actually, 107, whatever the number is nowadays. We peer with 3,500 plus ISPs around the globe. What this means is that your customer, be they in Thailand or Australia or India or the West Coast, can find a point in which their packets can enter our network very, very quickly. That's a key point, guys. Others will tell you, bring your packets to us, and they will take care of it. We actually give you a network where both for your public traffic through the peering side or for your private part through basically ExpressRoute and the like, you can get to us very, very quickly. So basically, this is it. We automate this whole network, so you ultimately can get your data in the right place. You can get computation to the right place, regardless where they may be around the globe. OK, enough of the background. Let's talk about the new stuff. So guys, we are, as we speak, rolling out performance improvements across the board, across the whole cloud, at no additional cost. That will improve the performance for every VM, anywhere from 33% to around 50% or so in bandwidth. The rollout will continue through the end of the calendar year. And for this thing, you basically have to do nothing. And what we owe you, by the way, is that a documentation in a few weeks from now on which SKUs have had this thing, which regions have had the rollout done, and the approximate ranges between these things. Give you a sneak preview. You'll be able to get anywhere from around 21 gig down to also ranges, 15, 16 gig, depending on the size of the SKU. These are big numbers, guys. When I say 20, 21 gig, that's without doing anything, guys. This would result into a number of advantages. Your own VMs, your own networks will become faster. And increasingly, services you consume from Azure, like storage, for example, will become faster as well. And you'll see more from those other teams telling you about using their language, the IOPS and the like, how things will become faster as well. This is OS agnostic. As you probably know, guys, a third of the VMs running on Azure today are actually Linux VMs. So this applies both to Linux and Windows. And as I mentioned, it's going to be global. It's rolling out as we speak. Numbers will start going up by themselves, to be quite frank. And the magic here, guys, other than some software optimizations, we've had some hardware in our network NICs that wasn't fully utilized. Now we got to it, if you will. So a lot of the encapsulation now is done in hardware, a bunch of other things as well. The dev leads actually are in the room, so if you want to know more how it's done, we can chat with them after the talk as well. And again, guys, this is being done across the board, no additional cost. You'll see it light up in the coming weeks, and by the end of the calendar year, the whole network will be upgraded. In addition, we're proud to announce accelerated networking. This is without a doubt the best cloud performance on the face of the earth as we speak in any public cloud provider out there. You can try to build this yourself. It will cost you an arm and a leg, and you end up with a small network with a bunch of hardware. With this, you're going to have consistent, low latency network performance. It's almost 10x improvement in some cases of latency. And all of us have application sets, have workloads that will benefit immensely from this latency improvement. Technically, we are providing SRIOV to each VM, which, as you see in a slide in a second, that means we're going to be bypassing software to do all sorts of things in hardware. Encapsulation, packet lookups, and so forth. This will increase the number of packets per second that your VMs and our infrastructure can handle, and will also reduce the jitter as well. And there's some apps in there where the jitter can be a big deal, to be honest. This is currently in preview. It's available for the couple of the high-end VM SKUs. And with those VM SKUs, you'll get up to 25 gig per second. I'll pause for a second, guys. 25 gigs per second. I'm not sure how many of us in this room have that capability in our current on-premises networks. It's actually hard to get these kind of numbers. We get these numbers in the public cloud, in a highly virtualized, isolated, secure environment. It's actually the first. My competition can maybe get to 20 on a good day. So that code actually is from the SQL DB team, and you're going to see more from SQL. That, for example, can translate into some benchmarks, in this case, 1.5x% improvements, in this case, an OLTP and memory benchmark. You're going to see that the amazing performance improvements that this team has done will trickle now into all those services. Databases, storage, your own apps, and with the usual commensurate advantages of lower CPU utilization, higher utilization, lower CPU utilization for the network, more packet processing per second, et cetera. For the partners in the room, that means your virtual appliances will run faster, et cetera. So guys, we are very proud of this stuff. It's rolling as we speak. It's going to be in public preview. If you want to use it, there's a blog out there. You have to send us an email. We'll enable you, and then we're going to roll it out slowly. Okay? You're going to see this thing rolled out this calendar year and throughout the next calendar year as well. And the differentiator between this one and the previous one, this gets you a lot more performance, by the way, and frankly, the latency part. The latency here is quite impressive. Okay? Okay. And by the way, we have talks about this thing in other sessions. Pictorially, very quickly, how this is done. Your left-hand side is how it's typically done. You may have your own VM on one side. You end up going through a virtual memory switch, a VM switch, basically, a virtual machine switch. You go to the host in every server. You go to the software, which is done by the CPU. You do things like you look up where the packet is going. You may encapsulate it in software. Then you go to the NIC, you go to the wire, and so forth. With this IOV is actually the actual hardware itself is mapped into basically the VM's memory. The first connection goes through the host, and then otherwise securely, the packets go directly to the hardware. And we have used how to utilize how the innovations to get this one done, guys, for example. You will see more stuff this afternoon in some keynotes about talking about the hardware infrastructure we did to make this thing possible. We had to invest happily, actually, in hardware innovations to make this thing a possibility. I will tell you more about it as well as we go along. Now, I want to ask Gabe. So I want to show you this thing now in practice, okay? So let's look at numbers. Let's look at speeds and feeds. And Gabe will show you more of this stuff in detail.
Thank you, Yusuf. Hello, everybody. My name is Gabe Silva, and I am a PM on the Azure networking team under Yusuf. And today, I will be showing you guys demos of accelerated networking. Before we jump into the demos, really quick, why do we need to do things like this? It's because customers just expect performance. It's one of those things that when you get it, it's just a checkbox on the list. When you don't get the performance, it's frustrating. You want to know why you're not getting 5, 10 gigs that you're supposed to be getting. So introducing accelerated networking. So to jump into the demos, let me get into the demo screen here. I've actually created 2 VMs in production in our US West Central region. And we can see that accelerated networking is actually enabled on these VMs by the virtual function. The virtual function is actually an adapter that talks directly to the NIC. So what I'm going to do first is I'm going to show you guys ping. We're going to do 100,000 pings here and show that we are talking from a sender here on the left to a receiver here on the right. And we're going to show you guys the types of latencies that we're getting there. Oops, sorry. So today, we typically see around 200 to 300 microseconds of latency between 2 VMs in the same availability zone. Here what you're going to see is that we're seeing roughly 30 microseconds. The majority of our packets, about 80%, more higher than 80%, are between 30 and 40 microseconds, equating to about 10x improvement in what you're seeing today. Now, I know this is a benchmark, and Yusuf has said we can get 25 gigs on a VM. So let me now show you a network stress tool where we'll keep Yusuf honest. And show you that we are, in fact, getting 25 gigs directly from one VM to the other. And this is running in production, no gimmicks. This is something that we will be able to enable for you guys soon. Now, I know you guys are thinking, these are just benchmarks. What can this do for my applications? Well, as Yusuf said, we've actually been working with the SQL team, and they've deployed their service on this cluster. So we have a few benchmarks that we've done with them, one with IOV enabled and the other without. And so first, we're going to go just show average latency. And this is just a read from the database that they've set up. So this is a client VM. It's going to actually ping the database. And it's just going to consistently ping. And you'll see the average running there up top. This is what you can see today. Now, with accelerated networking enabled, you'll see we're roughly at 4 and then slowly falling as it starts to warm up. It'll be 30 microseconds compared to 1.8. That's about a 6 times improvement there. Now, something a little more intense, we can do a throughput benchmark. And what this is doing is it's actually writing to the database. It's going to write, it's going to replicate, and then come back and send the ACK to the client. So we'll get that started. And you'll see here that we're doing roughly around 263 rows per second. Now, with the accelerated networking, we're at about 655 rows per second. That's about 2 times increase, a little more than 2 times. So your applications, you're all going to see the benefit of this coming soon. Today, it is in a preview, so you can go to the blog. It's for select VMs in select regions. We'll be enabling subscriptions as they come in. But once you do get enabled, it will be just as easy as clicking a button. You'll enable accelerated networking, and your VM will then be created.
How much does it cost?
It is free. So this is at no additional cost to you. I'm sorry, there's a question? Thank you. Was there a question? So we need to enable your subscription first, but then it'll be every individual VM will have it on the NIC.
And then we turn it on each VM.
Yes. No. We're
going to try to have some time for Q&A after the question. Okay. And there's a whole session on this, but we'll have a session on this thing. So, Gabe, done?
Yep,
thank you.
thank you.
Thanks, guys.
Let me get back to your slides.
Yeah, just. Perfect.
Yeah, sorry.
No. Good. Thank you very much. So, guys, that was the punchline. 25 gig, almost 10x, latency throughput, latency improvements, and we're all going to see it soon, basically for free. Now, it depends on the SKU you use, of course, and so forth, but we are very proud of this work. Let's move on, guys. Again, there's a whole session on this stuff later in the week. We'll give you the pointers as well. Let's talk about now, we told you about the global network. We told you about the amazing performance improvements we have done within the network. Let's talk now about some of the virtualization functions we've added to our system as well. So some of you may have seen this picture before. I'll speak very quickly. In a nutshell, the way you interact with virtual networking in Azure is like this. You can define virtual networks through APIs with a portal. In it, you can do things like define subnets. You can define ACLs, like network security groups. You can do load balancing into it, within it, and so forth. You can access it from the internet, if you so choose, of course. You decide these things. And you can reserve the IP addresses. You can do an IP address per VM or load balance IP addresses. And if you want to as well, you can use our DNS services, or you can use a third-party DNS service. And behind the covers, we have a a big infrastructure for DDoS prevention for the network itself. Now, you can also connect to the same virtual network through backend connectivity. And again, we'll tell you more about the improvements there in a second. You can come through ExpressRoute through private connectivity, bypassing the internet. Or you can come in through our VPN services, and we have a couple of flavors of those as well. Guys, this is a nutshell. This is an old slide, by the way, guys. What we have been doing for the last 2 years is refining this one slide, adding more features, giving you more and more control over the virtual network, almost as much as what you can do on premises. So in that spirit, let's talk about the new stuff. Our customers have been talking to us quite a bit nowadays. To be quite frank, people now use Azure for really heavy-duty enterprise scenarios now. And this is one of them, typically, where you end up with, in a sense, like a DMZ or a set of features like load balancing and firewalls done per workloads. So you see all these like silos, the left-hand side ones, if you will. A load balancer talking to a firewall, maybe an internal load balancer, a bunch of VMs, and so forth. That stuff works fine. But many customers are asking us, can they consolidate these common services into, if you will, common virtual networks? Can they put the firewalling functions, maybe IDS, IPS, load balancing functions in one place, and then distribute the traffic appropriately to other virtual networks? Well, now we can do this, guys. You can actually use virtual net peering to do what this red box shows in the slide. You can put centralized functions in one place, in one virtual network, control it, have the right people to control it, have the right monitoring for all the traffic coming in, and then peer that virtual network with other virtual networks in your data center. VNet peering is something we had in preview for a while. Now it's generally available. You can use it now for production. VNet peering gives you full mesh connectivity within any given region in Azure. You can build very sophisticated topologies with high bandwidth, low latency. It's becoming a theme, guys. Basically, you do it without any gateways. You're running basically at wire speed. So your VNets are not now anymore restricted by gateways and what have you. And you can do a topology like the one I described in the previous slide, where you decide to put your DMZ equivalency or your firewall equivalency in one and connect them in almost any topology you would like to. You can do a hub and spoke configuration, or you can do something more interesting than that as well. And again, it's GA. Actual billing will start on November 1st. There's a nominal fee for the traffic that goes between the VNets. And otherwise, the stuff is now in production. Go for it. OK, guys. So let's talk a bit more about building and running services on top of Azure. But I'm also very proud to announce that our Azure DNS service is now GA, generally available. We've had the DNS service for a while in preview. We feel very strongly about its capabilities now. And again, like many services I mentioned here, they're optional. You can go and buy a third-party DNS service if you want to. Or you can host your domains in our DNS service. With Azure DNS, you can manage basically your DNS seamlessly with your Azure services, subscription management, ACLs, all the stuff you do with our model. It's a fast global DNS system that utilizes our global network that I showed you earlier in the system. So the global network with the global locations around the network is where our DNS system runs. It has a 99.99 SLA for availability. And it can host all common DNS record types, including Quad A record types as well. And it's quite flexible, and you can use it through the normal means, through the portal, through CLI, RESTful, and so forth. And as I mentioned, it's GA now. So no more preview tag, no more saying it's not available for prime time. It is available for prime time now. And again, there will be half a talk on this subject some other time, either Thursday or Friday. I'll show you this list in a second. I'm also proud to announce that now we have IPv6 in Azure. So in Azure now, you can take load-balanced entry points in a load balancer, and they are native IPv6 load-balanced IP addresses. So clients can connect directly to Azure-based services that are IPv6 now. This is available globally in our network, in all our markets. And you can actually now have native dual IPv4 and IPv6 stacks here. This is not a native solution or a, smoke and mirror, if you will. This is a true IPv6 system. support for both Linux and Windows, and available globally as well. And there are many scenarios, by the way. I mean, some of you come from markets and segments that require or is demanding this service. For example, lots of mobile services are asking for this, IoT scenarios. Apple now have highlighted IPv6 support as a requirement going forward in some of their application set as well. And again, there are a lot of details here, but you can combine this thing with a DNS quad records and actually have a very powerful system running on Azure. So your application can support now IPv4 clients and IPv6 clients as well. OK. I said I'm going to move quickly, so I have to move quickly, guys. As a proof point, we have been running on this thing. This is just some of the guys running internally on IPv6 within Microsoft. We actually have been using in production for quite a bit of time by now. Because this was a multi-year journey by itself. You have to get the WAN to be IPv6 ready. Then you have to get all the data center networks to be IPv6 ready. Then you have to get the software ready. Then you have to get all the monitoring and infrastructure ready. So as you probably know, we dog food our own stuff. This is why we've been doing it. So we've been running at scale here. And if something goes wrong with many Office 365 issues within the company, trust me, my phone would ring. So this has been running seamlessly internally for a number of months now. So we feel very good about this stuff as well. By the way, guys, this is what we usually do, by the way. Before we tell you something is ready, we really go use it. OK. I'm going to switch subjects a bit here, guys. I want to talk a bit about load balancing extensions we are doing in the platform. This is a nice slide that describes a hierarchy of load balancers available in Azure. In the right-hand side is a simple picture of traffic coming from the internet. That's from the top. You typically can then use something like the Azure Traffic Manager, or you can use a third party if you want. You can use Akamai or whatever. But you can do that at that level global load balancing. That's typically done through a DNS global load balancing. Optional layer, but can give you things like deciding that traffic should go to this data center versus that, to this region versus that, or to failover globally, if you want. After that, you end up going through the Azure load balancer. This is our built-in layer 4 load balancer we've had from day one. That's the basic netting is done there. That's where layer 4 load balancing is done. After that, you can go and run basically network virtual appliances. We have a partner ecosystem you'll see in a second, or you can use our built-in application gateway. And I'll say more about the features we're adding to application gateway today. So application gateway is basically layer 7 load balancing. OK? And then you can go to the actual application you have in mind. So this is the basic picture. You can mix and match here. Other than the ALB, everything's sort of optional in this picture. So we've had the application gateway now for a year. And to be quite frank, it's actually quite popular in the marketplace. We've been having, these are old features that have been in the market for a while, guys. In a nutshell, it's layer 7, application delivery controller, the name in the industry for these things. You can do things like SSL termination. You can do session site management at the URL level. You can do content management, and a bunch of things in the back end as well. So the example in this case, you can, depending on the URL of the request, do certain things. Go for a video for this pool of machines. Go for the marketing side, the here and there, and so forth. Again, this is built in. It's a service managed for you, et cetera. What we're announcing today is that we're adding web application firewall functionality to it. With the web functionality, you now have the ability to do things like security additions to the basic application gateway. Same hierarchy I showed you when the traffic hits it. You now have web functionality in there. You can protect your apps from the web. And we actually used mod security and course rule set. It's a consortium out there. Lots of open source here in there. You can go see exactly what tools we have built in, pre-configured protection for the common attacks. And soon, you'll be able to customize your own rules as well. And if you know about mod security, this is mod security. So you know how this stuff really works. The documentation has been there for a while. No need to invent a new thing, if you will. But the beauty of this thing is built in the application gateway. So all the lifecycle management of application gateway basically applies as well to a firewall here. Quick question?
Is that a premium SKU then?
It's going to be a small add-on to the SKU, yes. This is this next slide.
In GA in a couple months?
It's currently in preview, but we will hopefully GA soon. We will not GA before it's ready, though. And you guys probably tell me when it's ready. We look at the adoption, we look at the error rates and the like, and we go. The thing we'll probably have to add before we make it GA is the customization of the rules. I like the built-in rules. They're very easy, and they do things like XSS attack protection and so forth, but customizing will be very useful to you as well. So to elaborate more, yeah, it is an add-on SKU to the application gateway. And the way you provision it is very similar to how you use the application gateway itself. It has a detection mode and a prevention mode. Let me explain this for a second. When you first deploy it, you may want to try it for a while, if you will. So you can do detection mode. It will tell you if it thinks you're being attacked. Or you can do a prevention mode. We'll actually go and scrub the traffic for you as well. It's optional for you. We've been investing quite a bit in monitoring for this service and others. The feedback from many of you has been very clear. Love the features, but you have to manage them. So monitoring is a big deal here. And okay, as usual, it can be managed through the normal means. PowerShell, Portal, SDK, and so forth. Again, it's in preview. You can go use it right now. In the spirit of talking quickly, because I want to get to our partners here quickly, we've also added multiple VIPs for load balancers. In a nutshell, this actually can really reduce your cost. Some of you may today have had to do things like use multiple VMs for your multiple, say, database pairs out there. With this, you can actually combine them with the same VMs, because the same load balancer now can handle multiple private VIPs on the same load balancer. And you have a lot more flexibility also how you do the port mappings. So you can now map the same port 80, say, on the front end and the back end, as of what we had to do in the past, change the numbers and so forth. It's completing the product, guys. So some of you will really understand how this stuff really helps you. Others will find it, okay, fine. I'm glad the guys have done this part. Quickly, a bit more enhancements. We've had Mac persistence behind the covers for a while. Most of you don't care about this thing. Some of you really care about this one, especially for some NVAs and virtual appliances. In the past, frankly, we had a bug in the past, guys, where the Mac may change on you. Now it's persistent. It actually has been there for a few months now. Then next two features actually are in preview. You'll be able to do load balancing for all NICs on a given VM, not just the primary one. And now you can have multiple IPs on the NIC. Now, the details go to the actual session, but why would you care? Because of the red line, guys. This really enables new virtual appliance scenarios. So I'm very proud to show a list of our current partners here. Some of them are in the room. The previous features you've seen in the last slide makes more and more of these scenarios actually possible. There have always been restrictions here and there. Now with multiple NICs multiple IPs per NIC and so forth, you're going to be able to complete the scenarios in multiple ways as well. OK. So I would like to switch gears a bit and show you first a short video of how a partner of ours is working with a customer of ours on a solution. And then I'm going to ask our partner to come up on the stage and tell you more about how they're actually using the system. So we're going to roll a video now.
The world of hospitality. It's a world of luxury and convenience, and a world that does over $150 billion in revenue every year. Recognized as the leader in worldwide hospitality, Hyatt has more than 600 properties worldwide, from London to New York and Beijing to Bangalore. Yet that worldwide presence leads to some world-class IT problems. For Hyatt, with their IT resources in a centralized data center in the US, increased demand around the world led to a huge increase in latency when logging into their enterprise resource planning servers. As their international presence has grown, so has the number of staff accessing their business-critical app servers, and more from an increasingly geographically diverse area. Application performance suffered from latency and impacted guest satisfaction. With a name that's synonymous with incredible customer service, Hyatt turned to Aviatrix and Microsoft for a solution. Aviatrix leveraged their enterprise cloud-defined networking technology along with Microsoft's Azure to deliver a scale-out solution with 20 times higher throughput and touchless provisioning to provide local points of presence to even the most far-flung Hyatt properties, reducing their latency to less than 10 milliseconds, providing redundant connectivity and enhancing security. And that's led to an increase in staff productivity, an increase in Hyatt customer satisfaction, and the ability to deploy more new apps. For the world leader in hospitality, Hyatt's partnership with Aviatrix and Microsoft has modernized the IT to be agile and efficient.
Yes, so please welcome Art. I would like to welcome Art here, and he'll tell us a bit more about the solution they've used. Thank you, Art. This one, this one.
Hello? Oh, there it goes. Okay. So my name's Art Chernobyl. I'm just going to talk a little bit about how Hyatt has been using Azure. Just to give like a quick history lesson, at the beginning part of this decade, Hyatt operated hotels kind of as islands onto themselves. We had hundreds of hotels across the globe, all running their own Active Directories, all managing their users, all having email independent. So we kind of started that journey. You know, we rolled out Office 365. We brought in Forefront Identity Manager, now Microsoft Identity Manager. We began to centralize how we deliver IT services to all our properties. And what that did was, as we kind of came to the tail end of that, it opened up a whole new list of challenges for us. We realized that excuse me, hotels, we had a latency issue when, even though we put read-only domain controllers at all our properties, anytime a write-back operation occurred, it had to come all the way back to our central data centers. Other issues that we were experiencing was how do we reduce the IT footprint at all our hotels? And that's when we turned to Microsoft Azure to kind of help us through some of those challenges. So what we looked at was how do we bring that application closer to the end user? One of our key goals was to decrease those login times, decrease our IT footprint at the hotels, and we looked at a new deployment for our ERP application, specifically in mainland China. One of the key challenges we had, and this is where we brought in Aviatrix, is we have over 60 properties in mainland China alone. How do we connect those to a single Azure region? The other issue that we had technology-wise was all of our hotels use Cisco ASA firewalls. Cisco ASA firewalls natively are static routing only. So how do we connect all those endpoints to a single Azure VNet? As we were going through all these challenges, Microsoft put us in touch with Aviatrix, and we discovered their Aviatrix cloud gateways. And what that allowed us to do, this slide, it allowed us to, one, bring our ERP application into that Azure region. It allowed us also to bring in read-write domain controllers into that same Azure location, as well as the added benefit of a system center distribution point, which allowed us to deliver patches, Windows updates, things like that, to the endpoints without having to reach all the way back to central data centers. So if you look at the slide just real briefly, everything kind of now, all these hotels, and we're just kind of representing a few of them here, all come in to the central Azure data center in Beijing, China, actually, and they get their ERP application from there, which connects back in a hub and spoke back up to Chicago. So what that allowed us to do, it brought down those initial user logins way down. We're now looking at, from I think when we did our baseline testing, that initial domain join would take a workstation anywhere from 5 to 6 minutes, you know, building the user profile, doing all that great stuff. That came down to under a minute. We also looked at, from a productivity perspective, all those users were able to now get their ERP application from a central region in Azure, as opposed to having to purchase hardware at each individual hotel. So we have our ERP application, standard multi-tier app, database layer, application layer. And when you look at the number of properties that we have out there, if you have to tell that hotel that they got to go buy 3 or 4 servers just to support an application, that's not really cost effective for those properties. Now all those properties just connect into a centralized system out in Azure. The excuse me, the other key factor that we got with the help of Aviatrix. Now we have a single pane of glass that we're able to look at all of our tunnel activity that comes through the Aviatrix gateway in a single view. We're also able to spin up hotels quickly by deploying additional gateways into those properties, configure all the routing. So now we're talking maybe minutes sometimes to get new VPN tunnels up and running, get a new hotel provision, get them on the ERP system, get them joined to our Active Directory, get those assets all under control. So basically, with the help of Azure and Aviatrix, we were quickly able to spin up new properties, get them going in the cloud, get them onboarded quickly, efficiently. I guess that's about it. Sorry, I'm not the...
No, this is great, actually.
So,
thank you. This is actually very impressive. Thank you. Thank you very much. Thank you. Thank you again, Art. So I want to tell you a bit more about our enhancements to connectivity solutions in Azure now. So as you probably guys know, this is, again, an older picture. You have multiple options today to connect to Azure. These are the built-in services, if you will. You have the VPN services, the multiple versions of them, point-to-site and site-to-site. And of course, you have ExpressRoute with the private WAN connectivity. And you can use them to connect to virtually any service we have running in Microsoft. That's basically the basic picture here. So I'm happy to announce as well that we now allow secure VPN transit using our VPN services. What this means is that, technically it means you can have BGP for redundant paths and dynamic routing. But what it really means is that you can build very sophisticated topologies while also transiting the traffic over our global network. Again, remember the big picture I showed you, our global WAN? We're giving you more and more ways for you to be able to leverage that WAN. So in this example, for example, you can build this topology relatively easily. Your on-prem side, your branch office, whatever the case may be, can enter our network, build a sophisticated VNet WAN topology running in the cloud that can transit back over our WAN to your sites as well. And with the power of BGP, the topology and the policies you control are actually quite sophisticated as well. And the guys are in the room with the whole session describing also options we have with this picture. So please attend those sessions if you're interested in more details as well. But this stuff is available today. In addition, we've added more high availability features for our VPN services. So the key of this slide is now we allow path diversity for on-prem networks. So the key of this slide are the two boxes to your hand side with a bunch of arrows that show on-prem VPN 1, VPN 2. You can now actually have a pair of them. So you can enter the VPN network from two different points. If you want to, from two different ISPs even. And end up with more redundancy with an active tunnel with BGP failover between them as well. And again, this is available today. And to complement this picture, we also now have active gateways on the Azure side. So in addition to the on-prem multiple device support, now our gateway itself can effectively have zero downtime if one of them goes down. And this is an active. We basically switch from an active to standby method to an active method. And trust me, guys, you'd be surprised how many of you are using this system for mission-critical systems. So we really had to invest in this thing. And I'm very proud to say that both the on-prem, ability to have multiple devices on-prem, and the active gateways are now available in Azure as well. And again, more details in other sessions on this stuff. For ExpressRoute, ExpressRoute, again, is our technology and service to allow you to connect privately to our network. We have now around 35 ExpressRoute locations, which is nearly double what we had a year ago or so. And the key point here, if you see an Azure region, you're going to have at least one peering point very close to it. That's our policy, guys. It's very close to it, so you can get to your data and application with the least amount of, if you will, latency. And as always, we also allow global connectivity through the network. So you can enter our network from any meeting point and hit any of our regions around the globe over our WAN as well. And the number really is really very much more than anybody else out there because, frankly, guys, we're very enterprise focused. And we know many of you have ExpressRoute connectivity to connect your backend networks to our Azure system because you're running heavy-duty enterprise applications. So we will continue to expand the system, guys. In addition, These are just a picture of where the sites are. And these are the sites we have for the government clouds. As you probably know, guys, we have a US government cloud, a German cloud, and a China cloud, separate from the rest of the global cloud. Because this way we can meet the geo-political situations, requirements, compliance needs, certifications as well. And they all have ExpressRoute meet me points specific for those clouds. And our global ecosystem has been growing. The slide is getting busier over the years here. But these are our major partners, and we have a long tail of integrators, other service providers who can help you or help your customer come to our system here. Guess basically, if you want to connect to us privately, we have a solution for you. Through a major telco provider, a major service provider, or somebody will help you to connect to somebody to connect to us as well. OK. I'm also proud to say that we have enhanced ExpressRoute by having a new SKU. It's the UltraPerf ExpressRoute Gateway. With UltraPerf Gateway, now we can get 5 gig throughput through ExpressRoute to a given VNet, which is a 5x improvement what we had today. You pay a bit more for that, but a 10 gig private connectivity, guys, solution, it's really, really difficult to buy otherwise. So this stuff is available. In addition, and perhaps I'm more proud of this one, we are increasing our SLA for the ExpressRoute Gateway to 99.5.5. This is the best cloud enterprise connectivity SLA out there, guys. Some my competition doesn't even have an SLA for the connectivity solution. We are increasing our SLA, guys. And I'll be honest with you, the way we're doing it, we've been increasing monitoring and the quality of the code, but the system has been very reliable, so I can afford to give you a higher SLA. Lastly, which is also very important, though, we are adding more and more insights into these systems. And I'm going to summarize toward the end of this point. But we now can have more self-help and troubleshooting tools for the ExpressRoute gateways. You have improved monitoring, diagnostics, and alerting, and on things like BGP routes, statistics for traffic, and so forth. This stuff is very important, guys. We have an SLA between our DMARC point and our network, and your provider may have also an SLA for their stuff. But you want to see what's happening in the network, and we're giving you more and more visibility into that stuff as well. Okay? And again, all the stuff is available now. So I want to switch topics a bit and invite Jason on stage. And Jason will tell us more about how they've been using Azure in their space. And then I'm going to come back and summarize some of the monitoring improvements we've done toward the end. Jason? Just turn it on. Thank you.
Test. Perfect. Hey, so I'm from Manulife John Hancock, and as I'm not sure everybody knows, but Manulife John Hancock is a financial services industry. We have 34,000 employees globally. We have 63,000 agents globally, and we operate in sort of the largest economies in the world, including Canada, which I like to say because I'm from Toronto. So our network has grown since we started playing with Azure, and I use playing lightly, but 3 years ago we started playing with Azure, and we started with a very small footprint, a very small use case, and we've grown from there. So right now we have actually empowered the business for high performance computing for actuarial science people for over 10,000 core hours. So these cores are available at quarter end periods, allow us to use it and not pay for it when we're not using it. So it's allowed us to modernize applications and do that more quickly to get us to a point where not only do they support the cloud, but they actually leverage cloud tenants. It also has allowed us to start embracing cloud native, and this is something that's new to us. We started in sort of an IaaS space where everything's about a virtual machine. People look at it as an existing data center, something that we just use like we would any other time. Someone requests a VM, we install an application, we go from there. But we're starting to move to Azure PaaS services and Pivotal Cloud Foundry. And these are supporting sort of flexible, dynamic applications that are going forward. Some of our past ones that we've done on Azure PaaS is our John Hancock Next platform, which was supporting Super Bowl ads. And we saw, I think it was 400,000 hits within 5 minutes of an advertisement being hit. And it handled it and globally load balanced it completely natively. We also did it for the Stanley Cup for our Canadian friends that are here. Same sort of thing. course, it was over 1 million hits. Just joking, but hockey is that much more. Yeah, perfect. So some of the things that have led us down this path is some core tenets that we have as Manulife. So the first one is infrastructure basically is bad. From a company, we don't want to have to pay money for core infrastructure, things that are needed to keep the lights on, because that takes away value from the business, value from moving to the cloud. And so this is a core tenet of our decision making. So we also look at modifying and modernizing applications instead of just moving them as they sit. So if we can't at least take advantage of one of the cloud sort of tenets, cloud values, then it may not be the right candidate for the cloud. But we've been able to do this for applications that are really not flexible by partnering with key vendors and working with them to bring their applications to the cloud, even with just a version 1 approach in an IaaS virtual machine. And we've been able to do this extremely well with our actuarial software. So the third tenet that we sort of stick to is we decided to align our regional pairs with Microsoft's DR regional pairs. So this is important because it gives the control to us from a disaster recovery standpoint if Microsoft switches or flips the switch on a region, or if we choose to do it from a business need standpoint or a certain service that's down, we can actually do that DR in the same manner, and it's always consistent from a data replication, from a data access standpoint. And then finally, we encourage always on and distributed applications so that we can actually keep things on and running on a regular basis. So I'm going to walk you through our journey. So we started in 2013. We started with a IPsec VPN. I know, it's exciting. We started with one. That's it. So we started because it was easy, and it was still in that sandbox, that science experiment level. And we had a few VMs, a couple subscriptions, and just played. And this is where we proved out a concept that we could actually burst to meet the demand of our actuaries and be able to move forward. In 2014, we said, you know what, this is really working. So we bought an ExpressRoute, we connected it up, and we started with our first 2 regional pairs. This started the onslaught of business applications, of other services that came in. And it really basically sent the word to the rest of the company that we're ready to start picking up. But it also drove, based on use cases, our network growing as a global capacity. So in early 2015, we started getting our Asia division engaged. We also put a VPN there. And it did the same thing. It proved that it worked, and everybody was on board. So in mid-2015, we realized that, okay, we're going to productionize Asia. We have ExpressRoutes there. We get our regions set up there as well. We have more regions added in the US. And then we started realizing that we were duplicating a lot of our core infrastructure, and this goes back to tenant 1. What are we going to do? Because our costs are starting to erode the business value that we were deriving. So we enabled ExpressRoute Premium and cross-connected across the ocean. This gave us immediate relief. It allowed us to have what we started to coin as a common core services subscription. It hosted all of our infrastructure, and it had presence in most of the regions that we were existing in. But because our virtual networks were getting up there in counts, as we had different regions and different subscriptions and different people managing it, we sort of built the subscription model that instead of costing centers, we looked at who's going to manage it and how is it going to connect to it. And where those two things crossed, we said, okay, that's where a subscription makes sense. Because when you're a large enterprise, you have 30,000, 40,000 charge codes, a subscription does not make sense as a billing demarcation point. So the problem with that, though, is as you have different connectivity and different managers, you get an increased number of virtual networks, and you have to connect them. And because we have multiple ExpressRoutes, you've got to cross-connect them. And when you have 30 to the power of 30, it becomes very difficult to manage. So we started shifting into a different approach in 2016. So early 2016, we merged MPLS clouds. So what this allowed us to do is have one global MPLS network, which our ExpressRoutes were joined to. And we were able to sort of bridge the divide between physical connectivity that we could drop where we needed it and the logical connectivity into each Azure data center. It gave us more efficient routing to each of the zones, from our primary zones and our DR zones, allowing different routing to both. It also allowed us to enable more efficient routing so that someone sitting in Asia could access a global solution that was hosted in North America without having to traverse our existing legacy WAN, which was a nice reprieve for all of our users. So as we continue down this journey in 2016, we continue to add more and more regional networking and more physical ExpressRoute terminations. And there's no stopping, it seems. We're currently at 55 virtual networks, over 2,000 virtual machines in our environment, and we're just getting started. So one of the things about this global networking that's important to point out is that you can have physical connectivity without having your logical connectivity. So this allows flexibility so that I can cross-connect or connect to appropriate regions to the nearest ExpressRoute that we already have. And those physical connections can drop into regional data centers, can drop into major data centers or offices, so we can have an efficient route. And it's been able to empower a lot of user global-facing applications. So our basic response or results here. It allows us flexibility and connectivity. So we can focus on the actual solutions, the business needs, the use cases, and not how we're going to connect it up. It's allowed us to cut duplicate resources from infrastructure. We've been able to have central resources that handles everything, so we don't have to have multiple per virtual network or per subscription. And then finally, it supports connectivity at scale. And this is something that continues to be paying back in order, is because we've been able to grow it from use cases and continue to grow it over the global scale, we just can keep adding capacity, adding use, and have no issues. So our future. So as I said, we're going to continue to expand, but we're going to look at more and more cloud-native approaches that are highly distributed in nature, self-managing, and able to be continually developed. We're going to extend distributed security zones, looking to minimize further infrastructure. And this plays into one of the actual announcements today, which was the VNet to VNet peering, which we've been testing with and building out our plan on this one. So this allows us to have what we've sort of marketed as a global control zone. And it's the new term I've coined for at DMZ. So it allows us to separate our presentation tiers to put them near the applications and have our security layers at a regional level. And then finally, we're able to sort of leverage more high-performance networks, again, with one of the announcements today. Our actuarial compute expects low latency, and this was a godsend to have coming. Under a millisecond latency is fantastic. It is going to allow us to be able to run at even higher scales than what we're at now and be able to close out further gaps and make it more available for our actuaries. There we go. Back to Yusuf.
Thank you, Jason. It's always very satisfying for many of us, our presentation and Jason's presentations, to see people using our stuff. You know, guys, many of us are sitting in our offices, in Redmond, Dublin, China, Sunnyvale, wherever we're a bunch of places, guys. We write software, we envision how you guys are using our system, so it's always amazing to see how the usage is actually happening. Okay, guys, we're in the home stretch, I'm almost done. We want to tell you about one last topic, the investments we've been doing in monitoring and diagnostics. And the message from many of you is really very straightforward in this space. You're using us for real, we must enable you to be able to have visibility into those virtual networks that are running in our regions. So the path we've been on, and guys, it's been a journey for the last year or so, is to give you more and more deeper insights into your network. And the key operative word here is your network, yours. So in this picture, you see how some of the points in which we are adding more visibility and monitoring diagnostics so you can see how things are coming into your network. So in ExpressRoute, for example, now we have more and more capability for you to see the traffic coming to the gateways. I alluded to that a few slides ago. Diagnostics, alerting, BGP routes, and more statistics as well. Similarly, for the points which have all these sort of spyglass type of symbol, if you will, we're adding more at the load balancer, at the NSG level, which is the ACLs part, at the back ends as well. So ExpressRoute, we can now see more about your peering connection statistics. You can see more information about your R tables, route summary, and routing tables. For virtual networks, you can see the effective security rules on every NIC. That's been very highly asked for, but to be honest, guys, because you're going to define your own rules. You want to see what's really the effective rule on the NIC. And you also see the information such as the next hop and effective rules for every NIC in the subnet as well. And again, when you guys start using the system, this stuff will become very, very useful. And lastly, and you can see the nice icons flickering here, for the application gateway itself, we have a lot more metrics and alerts. And we have more information about back-end health of the VMs you're basically talking to as well in there. So guys, you can see more of this stuff lighting up. We have big investments happening in the portal experience, as well as the command lines to get this information, and also in extracting the logs and diagnostics and moving them to third parties and the like. And you'll see more of us coming in this space as well. So please stay tuned as well. Okay, guys, it's been a long day, a long presentation. I'm going to summarize this, show you the presentations which has more information there. So in summary, we have the best performance in any public cloud as of today. It's through accelerated networking and get 25 gig, and really very fast latency. We have been adding performance improvements across the spectrum, guys, for every VM in the system, to the ultra perf gateway, and of course VNet peering, which runs at speed. We're upping the ante as far as availability is concerned. So our SLA on the gateways for VPN and ExpressRoute have been increased. And our functionality for HA has been increased. You saw the stuff for active VPN, and the ability to have multiple path and transit routing for our VPN services. We'll give you more options for security. So if you want to, you can use now our application gateway web application firewall. It's an optional SKU, gives you more control on application level control. And of course, we have more capabilities here. We have the GA of Azure DNS. We now have native IPv6 for Azure VMs. And we have a lot more enhancements, which I will not read you the list here, on the NICs and MAC persistence and so forth, which will make your NVA or your virtual appliance scenarios richer. And finally, we continued the march in improving marketing and diagnostics. Last slide, I promise. These are the sessions coming up. 1 on Thursday, 3 on Friday. Take a picture of this, please. And tell us what you want to hear, by the way, because frankly, the slides are still evolving. So we can add stuff, we can remove stuff if you want to. There's a session on Thursday. You'll know a lot more about actual usage and the details of ExpressRoute, and how customers are using it. On Friday, the first one in the morning, you'll know a lot more from Ross and Yushin on connecting, securing all the VPN solutions, lots of connectivity discussion in there. In the midday, Narayan and John will tell you about a bunch of things we're doing at the VNet level, how we're actually doing VNet peering, the multi-NIC discussions we've had, and so forth. And you'll know more on Friday from Eric and Emmet on both the DNS service we're doing, as well as our application gateway extensions with the WAF and so forth. Yeah. Gabe, which session will you have more stuff in there for accelerated networking? Narayan's and? Okay, fine. So next to last, we'll have accelerated networking details as well. Okay, guys, we're done. We have 5 minutes. Come over to the stage. And thank you very much, otherwise, for your attendance.